Hello, my name is Elliot Cassidy, and in this video I'd like to walk through the solution to question 3, shirts, from the 2008 British Informatics Olympiad. If you haven't already, please pause now to review the problem statement shown on screen. We can represent the order of shirts labelled 1 to 7 as an array. As specified in the question, the only operations we can use to modify this array are 1. Move the first element to the middle, shifting the remaining first 3 elements to the left. 2. Move the last element to the middle, shifting the remaining last 3 elements to the right. 3. Move the middle element to the start, shifting the first 3 elements to the right. 4. Move the middle element to the end, shifting the last 3 elements to the left. This resembles this tree structure from graph theory. I highly recommend you read the section on graph theory in the Competitive Programmer's Handbook, which I have linked to in the top right hand corner of the screen, if you are new to graph theory. The root node of a tree in our case would be the starting array. Each operation that we perform on this array generates a new child node. Our goal is the sorted array, which we will consider a leaf node because no further operations are required to achieve sorting. The shallowest occurrence directly gives us the minimum operations, as the level of the leaf node is equal to the number of operations performed. When generating child nodes, we track visited states to avoid redundant checks. Revisiting a state would lead us down an already explored path, and since we are looking for the shortest solution, we can safely avoid these duplicates. To determine the shallowest level where the sorted array appears, the first idea that may come to mind is to traverse each branch of the tree to its steepest level before backtracking. This approach to searching a tree is known as depth-first search. Since each node branches to 4 children, this yields a time complexity of O of 4 to the n, where n is the tree depth, placing it in exponential time. Consequently, the number of operations increases massively as the tree gains layers. This makes DFS particularly inefficient since we only need the shallowest solution. Thankfully, there exists a graph traversal algorithm which is vastly superior to depth-first search in this instance, breadth-first search. This is how it works. All nodes at depth 0 are explored, then all nodes on depth 1 are explored, then depth 2, and so on, until a leaf node is found. When this method is used, the first occurrence of the sorted array will also be the shallowest solution, which means we don't have to iterate through every path, making it far more efficient than depth-first search for our purposes. In fact, because our tree will only have a maximum of 5040 nodes, this code is effectively in constant time for this fixed problem size of 7 factorial, or 5040 nodes. Now that you grasp the core concepts behind solving this problem, I encourage you to attempt implementing a solution to this problem yourself. It's an excellent way to solidifying your understanding. Afterwards, you may find it useful to compare your solution against my annotated solutions available in the GitHub repository linked in the description below. If you found my video valuable, I would appreciate it if you could leave a like, and if you'd be interested in more content like this in the future, please do consider subscribing. Thank you for watching.